second lesson in our exponent unit, we are going to be looking at powers of 10 and how to change a number that's written in scientific notation into standard form. And it's actually quite simple once we come up with a pattern of what's going to be happening every time, because we're going to be doing the same thing every time. So it's actually going to be really simple once we figure out what that pattern is. So that's what we're going to do first. See if we can figure out a pattern for when we're looking at powers of 10. So we're just going to go through this list, see what we notice. First of all, what is 10 to the first? In our last lesson on exponents, we talked about how to solve exponents. So 10 to the first just means 10 written one time, which is 10. 10 to the second power would be 10 times 10, which is 100. 10 to the third power means 10 times 10 times 10. Oops. I'm using my mouse today instead of my InWrite pad, so my handwriting is not the greatest. But 10 times 10 times 10, which is 1,000. And 10 to the fourth power is 10 times 10 times 10 times 10, which is 10,000. So now if we look at our answers, we'll see if we can find some sort of a pattern. Here we have 1 0, here we have 2 zeros, here we have 3 zeros, here we have 4 zeros. If I look at all of my exponents, I notice that here is 10 to the fourth power and we have 4 zeros. Here we have 10 to the third power and we added 3 zeros. Here we have 10 to the second power and we added 2 zeros. Here we had 10 to the first power and we added 1 zero. So when we're doing powers of 10, the number of zeros matches up with the exponent. That's kind of a pattern that might be important. So now we're going to take this just a step further. And we're going to actually see a number in scientific notation, which is what this is right here. A number times the power of 10. And we're going to see if we notice any sort of pattern here. So 3 times 10 to the first means 3 times 10, because we know 10 to the first is 10, which is 30. Here we have 3 times 100. We found out on the last page that 10 to the second is 100, which gives us 300. Here we have 3 times 1,000, which is 3,000. And here we have 3 times 10,000, which is 30,000. So you notice in this problem that the number of zeros are still matching up with their exponents. That is part of the pattern that we notice, but that's not going to happen every time we multiply by a power of 10. But something else that I do notice is that if I were to put in a decimal point right after these 3, because that's where it invisibly is, even though it's not written, I notice that from the problem to the answer, I moved the decimal point over 1 spot, 30. Here I moved it over 2 spots, which gave us 300. Here I moved it over 3 spots and got 3,000. Here I moved the decimal point over 4 spots and got 30,000. So I noticed that the number of spots I moved the decimal matches up with the exponent. And that is actually what our pattern is, what's going to happen every time. When you multiply by a power of 10, you're going to move the decimal point to the right as many spots as the exponent in the problem. Which makes it very simple. We don't have to be multiplying out these very, very large problems. So here's a number written in scientific notation. If a number is written in scientific notation, that means there's one number to the left of the decimal point, and then all the numbers the other numbers are written to the right, and then it's multiplied by a power of 10. And what we're going to do is write that number in standard notation, which means written out with the decimal point at the end and all the zeros added on that we needed. So like we have up here, we're just going to take the decimal point and we're just going to move it over however many spots that the exponent is. And that will give our answer in standard notation. So we're just going to try a few of those. We won't do all of them, we'll just do the first few. Here I have 12 times 10 to the third. The first thing that I need to do is write down the problem and put the decimal point in there. Whenever a decimal point isn't in the problem, that means it's after all the digits that are there. So this would be like 12 and then a decimal point after that. And then it says times 10 to the third, which remember, whatever the exponent is, That's how many spots I'm going to move the decimal to the right. So I'm going to move it 1, 2, 3, and fill all those spots with zeros. And then I can rewrite my numbers so you can see what it is with all the lines and everything on there. And I get 12,000. So 12 times 10 to the third is 12,000. All we had to do is move the decimal 3 to the right and add zeros in. Here I have 225 times 10 to the 7th. Again, there's no decimal point in there, so I'm going to put it at the end. 225 and a decimal point. And now it says move the decimal 7 spots to the right. So I'll move it 1, 2, 3, 4, 5, 6, 7. And we could add all of our zeros in there, and we would end up with 2, 2, 5, and then 7 zeros. 1, 2, 3, 4, 5, 6, 7. Put some commas in there, see if you can read this number. Hundreds, thousands, millions, billions. So 2,250,000,000. Now, this number here, and this number here, and this number here, actually all of them that are listed, they're not technically in scientific notation because there's more than one number to the left of the decimal. If I wanted a number actually in scientific notation, we would have to have the decimal point right after the first number, or the first digit of each of these columns. So technically they're not in scientific notation, but we're going to write them in standard form still. So let's try one last one, just to make sure we got the idea down. So here we have 34 and 9/10. So I'm going to write it down again. And in this case, the decimal point is already in there, so I'm going to leave it where it was. And I'm going to move the decimal 5 spots to the right. And in this case, we can see that we're not going to be adding 5 zeros on this time because of where the decimal was. We're only going to be adding on 4 zeros. So I will end up with a number in standard form of 349 and 4 zeros. I can add some commas in there, and we're left with 3,490,000. That's that number in standard form. Now, if I wanted to take a number and write it in scientific notation, remember that means there's only one number to the left of the decimal. You can use this one for an example. I would rewrite the problem so there's one number to the left of the decimal. And since I moved the decimal 1 to the left, I'm going to add on one more number to our exponent, so that would be 10 to the 7th. So these two numbers are the same. This number is actually written in scientific notation, whereas this one is not. So just remember, when you're changing a number and you're multiplying by a power of 10, you are just going to move the decimal point to the number of spots that the exponent is in the problem and add a 0.